absolute refractory period and relative refractory period. When we say anything is refractory, if it doesn't respond to stimulus or it doesn't respond, we say it is refractory. When we say a cell is refractory, in this case we say refractory means a cell doesn't respond to the stimulus, we say the cell is refractory to the stimulus. So how do we define absolute refractory period and relative refractory period? Absolute refractory period means the cell is in absolute refraction. That is, no matter how strong the stimulus you give, the cell will be an absolute refractory period. The relative refractory period means the cell will respond to stimulus, provided the stimulus should be larger or should be of greater strength than the normal stimulus required for that cell to fire an action potential. That period is called, that means the time period in which the cell responds to stimulus which is larger than the normal stimulus required to fire an action potential. That time period is called relative refractory period. When are these time periods? Absolute refractory period is from peak potential to resting membrane potential. Why it is called means, we know at the peak potential level all the sodium voltage gated sodium ion channels start closing. That is, they shift their configuration or they shift their state from activated to inactivated. So from here all the sodium ion channels will be in inactivated state. When the voltage gated sodium ion channels are in an activated state, slowly they transfer back to deactivated state. This transfer from inactivated state to deactivated state, in that particular time, the voltage gated sodium ion channels are closed, as both inactivated state and deactivated state are both closed configurations. From here, from the peak potential to the resting membrane potential time period, in that time period, the voltage gated sodium ion channels shift from inactivated to deactivated state, both are closed. So in this time period, voltage gated sodium ion channels are closed. So no matter how much strong the stimulus you give, there is no depolarization or there is no constitution in the membrane potential. So if there is no depolarization, obviously there is no firing of action potential. So we call this phase as absolute refractory period. When the cell reaches resting membrane potential, all the voltage gated sodium ion channels will be in deactivated state again. So they are again open to a stimulus. They will receive a stimulus and they will cause depolarization and they can fire an action potential. But the membrane potential doesn't stop at resting membrane potential, it falls down. This after hyperpolarization, it goes down, it goes into negative value. When you give the stimulus at this particular point of plus of some value, it requires more stimulus, it requires more voltage to reach threshold voltage. Say from resting membrane potential to threshold voltage, it requires a less greater potential than from after hyperpolarization to threshold voltage. As with an eliciting action potential, though with an eliciting action potential, we require more strength of the stimulus in this particular time, that is after hyperpolarization. This phase we call it as a relative refractory period.